Factor by grouping with 4 terms. Now, when you factor by grouping, you're going to split it down the middle, and you're going to GCF both sides. So for the GCF between 42 and 48, we can divide those both by 6. There's also a k squared. There's a k in both. Go with the lowest power. Now we divide by 6k squared. 42 divided by 6 is 7. K cubed divided by k squared is k to the first. If you got 3 powers of k, and you factor 2 out, you got 1 left. And then, 6 times 8 is 48. So 48 divided by 6 is 8. And k squared over k squared cancels. Now we'll GCF the right side. You can divide those both by 5. Now the key to doing this, you know you're right because those parentheses will match. The way the rest of it works, this is multiplication on each side, and these match. So it's like they're common to both. So you can pull it out of both, only write it once though. And then what's left over on each side, the 6k squared, and then the plus 5, those are what's left over to become the other factor. Number 2, split it down the middle again. I can divide both 6 and 9 by 3. We'll also go with x squared. So 6 divided by 3 is 2. X cubed divided by x squared leaves you with x. 3 divided by 3 is 9. The x squared is gone. Now, like I said on the last question, your parentheses have to match. And the problem here is that the left side is a positive and a positive. The right side is a minus and a minus. So when you need to switch the signs to get them to match, don't factor out a positive GCF, factor out a negative. Like for the right-hand side here, if I divide by -7, negative 14 divided by -7 switches that to positive 2x. Minus 21 divided by -7 switches that to plus 3. That way your parentheses will match. So you can take out that binomial out of both of them. Only write it once though. The other factors, what's left over? 3x squared minus 7. Now 3, split it down the middle. You can divide those both by 5k squared. Five divided by 5 is gone. K cubed over k squared leaves you k to the first, or just k. 25 divided by 5 is 5. You factored out all your k squareds. Now again, the signs aren't going to match up. But anytime you got to reverse both signs on the right side, divide out a negative GCF, so I'm going to divide out -4. Leaves you positive k, positive, so plus 5. So pull your k plus 5 out, and you're left with 5k squared minus 4. Number 4, well, I can't divide a 4 and 5 by anything, but there's the x's there. So the GCF is x squared. Leaves you with x minus 5. Excuse me, 4x minus 5. Now, on the right-hand side, there's no GCF. You can't divide 4 and 5 by anything, and there's no x with the 5, so there's no x GCF. And if you notice, that already matches our, in parentheses, 4x minus 5 on the left. So we want to factor something out that won't change when I divide. So I'm going to factor a positive 1 out. And you don't really have to write that plus 1 there. It's not a bad idea, though, only because when you take those out of both as a GCF, we got the x squared left over on the left side, but on the right side, you need something left over. So that something's got to be that plus 1. That's why it can't hurt to write it down, to make sure that you put it in the second set of parentheses. All right, so that's a quick little rundown of the factor by grouping. Now the next one is another factor by grouping, but instead of 4 terms, we'll have 6. It's done the same way, though, for the most part. We'll still split it right down the middle. There's an x in all of those, so I can factor an x out. So if you divide everything by x, just drops the powers down, x squared plus 5x, and on the last one there is no more x at all. Now on the right-hand side, there's no x with the 12, so there's no x in our GCF, but I can divide all those by 2. Now this time, instead of a binomial matching, I have a trinomial match. So we pull that trinomial out. And what's left over is x plus 2. Then you got to think, well, hey, that x squared plus 5x plus 6, I can keep factoring that. That's just a regular trinomial. And I can factor it because there are 2 numbers that multiply to 6 and add up to 5. And everything's positive here, easy case. 2 and 3. And just bring the other x plus 2 down. Number 2, split it down the middle. The GCF on the left is a 3. Divide those all by 3. You're left with x squared minus 1x, or just x, minus 20. On the right-hand side, there's an x in all of them. So you can divide by x. Oops. Then that'll just knock the x's down to make them match. So we got x squared minus x minus 20. You pull that out of both sides, and you're left over with 3 plus x. And then again, take a look at that trinomial. Ask yourself, hey, can I factor that? Yes, I can. Minus 5 and plus 4. Now, the 3 plus x, I mean, we could just leave that as 3 plus x. But just to be consistent, it's just addition, so it's easy to just change it to x plus 3. Not a big deal, though. And now 3, same idea. Split it down the middle. There's a GCF of 2 on the left. So just divide everything by 2. And then on the right, there's a GCF of x. So again, we'll take that trinomial out from both sides. Only write it once. Then what's left over is 2 plus x. Ask yourself again, can you factor that trinomial? Yes, you can. Minus 2 and minus 8. They're both minuses because that 10 in the middle is negative. Then just bring the other one down. I'll switch that to x plus 2 as well. Not a big deal if you don't. And number 4. Split it down the middle. Now on the left, there's no GCF. There's nothing you can really do there. But I gotta have something that when I take that trinomial, when I factor the trinomial out in the parentheses, there's gotta be something left over. So again, we're gonna divide by 1. You don't really ever want to do that to try to actually factor. But here, I just need something to have to be left over. You can either write that 1 down or just keep it in your brain. Just like x is the same thing as 1x. On the right side, I can factor out a 3x. Divide those all by 3x. So you get x squared plus 4x plus 4 leaves you with 1 plus 3x. Here, let me be consistent. You take that trinomial out. Now you're left over with 1 plus 3x. And again, 2 times 2 is 4, 2 plus 2 is 4. We'll factor this trinomial. Not a big deal. I'm going to switch it to 3x plus 1. You could leave it as 1 plus 3x. So that was factored by grouping with both 4 terms and 6 terms. The next kind of factoring, and though those last 2 were kind of review, the 4 term was definitely supposed to be review. The 6 term was supposed to be new, but I mean, the 6 term wasn't much more difficult or even different. But this is different. We're going to factor the sum and difference of cubes. It's got to be a perfect cube. So we're going to be thinking about numbers like 1 to the third is 1, 2 to the third, 2 times 2 times 2 is 8, 3 to the third, 3 squared, 3 times 3 is 9, times another 3, 27. 4 squared, or excuse me, 4 cubed. 4 times 4, 16, times another one, 64. 5 cubed, 5 times 5 is 25, times another one, 125. Then 6 cubed is 216. 7 cubed is 343. And if we need any more, we'll have to cube some more. The way this works, you want to drop it down to whatever you would get if you take the cubic root. And if you want to take the cubic root on your calculator, you hit math, and it's choice 4. It's a radical with a 3 in front of it, cubic root. Now what that means is, what do you multiply by itself 3 times? Like what we just did. We got to drop it down to what you would cube to get what's in the question, cubic root. Then, the form of the factoring, and I'm going to delete these. I need the room. Maybe I'm not going to delete them. Let's try this again. Hey, there we go. The form, and the reason that this is called SOAP, this part you got to memorize. The first one, then the second one. Then you make a trinomial-sized pair of parentheses, square the first one, then multiply them, square the second one. Where the SOAP thing comes in are the signs. Same as the question, opposite of what you just wrote down, SO, and then the AP and SOAP, always plus. Same, opposite, always plus. So, all right, well, we got to drop this down to the cubic roots. The first one's easy. You raise u to the third power to get u cubed. The second one, 27, the cubic root of 27 is 3. I just erased that. 3 to the third power is 27. Now, for the A's and B's, and this was the hardest part for people in class, you don't use these. You don't use that, or else there would have been no point to what we just wrote down. You use this for A without the cube, and use this for B. Again, it's just those numbers that are in the parentheses, or the variables in the parentheses. So for my trinomial one, I square the first, u squared, then the middle I multiply them, u times 3, 3u, and then square the second one. 3 times 3 is 9. Now do the SOAP thing. The first sign, SOAP. Same as the question for plus, then the opposite, minus, always plus. Done. And number 2, drop them down. Well, I would raise 3x to the third power to get 27x squared. I raise 5 to the third power to get 125. So a binomial, then a trinomial. First one, second one. square the whole first 3x, so 9x squared. Then multiplying 3x times 5, 15x. Then square your 5, 25. Same as the question, plus. Opposite then minus, always plus. And there we go. Number 3. Well, 343, I had erased that. That was 7 to the third power. So 7m cubed minus the cubic root of 64 is 4. And this should be pretty easy after you kind of get the hang of it. After you start doing them, you do start to do them faster. So the first one, then the second one. And after you get used to it, if you just want to fill the signs in as you go for it. 7m, you got to square it. So 49m squared. Then multiply the two things in the parentheses together, 28m. Then square the second. 4 squared is 16. Same, this time it's minus. Opposite plus, always plus. Number 4, that'll be 3u to the third and 7 to the third. Three u and then 7. The first one, then the second one. Then the first one squared. 3 times 3, 9. U times u squared. Then you multiply them, so 21u. Now you square the second thing. 49. Same minus, opposite plus, always plus. All right. So that was a little crash course on that one. Now there's one more. This should be review from algebra. Now, whether or not you've seen it or remember it, it's okay. We're reviewing it. Now, there is more than one way to do this. Everyone in class chose to do AC factor. If you did learn this in algebra and you did it a different way and you need help, I can help you with it. But for AC factor, you recognize to do this when there is a coefficient on your x squared, or in this case, n squared. When a, which is the number in front of your square variable, is not a 1. And also, it's not a number that would just disappear as a GCF. You can't divide 12 or 20 by 7. So that 7 isn't going to go away as a GCF. Now, what you do for AC factor, first step. Is you multiply A and C. That's why it's called AC factor. And you're going to write that off to the side. So 7 times 12 is 84. Now you want two numbers that multiply to 84 and you add up to the 20 that is in the middle. And it happens to be 6 and 14. And just a reminder, if you need to, on your calculator, you can put 84 over x and then go through the table. Now, what you want to do, once you find those numbers, split your middle term into those numbers with the variable. Oops. On there. We can do this because 6 plus 14 is 20. So I'm going to say 6n plus 14n. Then you drop the other n's down. Now the rest of it is just what we did for the very first type of factor. Split it down the middle, and we'll factor by grouping. That's the last step. Factor by grouping. So GCF on the left side, and it doesn't matter. I could have put the 14 first, then the 6n second. It doesn't matter as long as those two numbers actually add up to the middle or combine in whatever way you need the signs to be. So there's a GCF of n. On the right side, there's a GCF of 2. Pull those 7n or plus 6's out, write it once, then what's left over is n plus 2. Now I'm going to delete the rules here. Maybe. There we go. So again, a is the first number in front of x squared. Usually, like if there's no number, that's a 1. Again, that's the difference. I got a number in front of my x squared. That is not going to go away as a GCF. First number's A, second number's B, third number's C. You want to multiply A times C first. 3 times negative 15 is negative 45. Now I need two numbers that'll multiply to negative 45, but combine to that plus 4 that's with the x, the number in the middle. 9 times 5 is 45, and 9 minus 5 is 4. I'm going to use 9 and negative 5. Now, it doesn't really matter. I can absolutely put the 9 first, but I'm going to put the negative 5 first, and I'm not going to forget my x. And I'll say why I chose to do that in a minute. It's not a big deal. Bring the n's down, split it down the middle. I got a GCF of x that I can factor out. Now here's why I put the negative first. The negative 5 first. I'll have a plus minus on the left and a plus minus on the right. So I don't have to worry about dividing a negative out to make the signs match. It's not a big deal. It's not that hard. Just sometimes, you know it, people forget when there's a double negative. So then they get confused because the parentheses don't match. So it doesn't really matter. But this way, I don't even have to worry about that. I can divide by 3 on the right-hand side. I don't have to worry about any double negatives or anything. Pull out that 3x minus 5. You're left over with x plus 3. Now, number 3, a times c, that's 180. And you want two numbers that will multiply to positive 180, but add up to negative 36. So they both got to be minuses. Well, 6 times 3 is 18. 30 times 6 then would be 180. And 30 plus 6 is 36. We got our numbers. They're both negative. And again, this time it really doesn't matter. You can put either one first. Maybe you'll put the 30 first. That's absolutely fine. Just don't forget the R. Split it down the middle. Hey, I can divide those both by 3 and an R. So you get 3R left over, minus 10. Oh, this time we didn't have a choice because both the 30 and the 6 were negative. You notice the left-hand side is positive then negative, but the right-hand side is negative then positive. So I got to switch the signs around by dividing by a negative GCF. So I'm going to divide by negative 2. That'll switch it to positive 3R and minus 10. So then I'm good to go. They match. The parentheses match. I can pull out the 3R minus 10, and what's left over is 3R minus 2. Number 4. Hey, number 4 here is kind of an example of, the hardest that this gets. When I multiply A times C, again, it's A, B, C. So I get negative 900. Well, okay. That's a decent sized number. There's going to be a lot of factors. Don't forget. Go to your calculator. We'll pull up the calculator here. Y equals, what was it, negative 900 or pause? It was negative 900 over X, second table. And boy, we got a lot of ones to try in here. So I need them to combine to negative 80 in the middle. So since we're multiplying to negative, and as you can see on the calculator, there's one of each. So it'll be like they subtract to negative 80. And there's going to be plenty to go through here. We'll keep on looking. I wonder if I already went past it somewhere. Well, we'll see pretty soon here. We'll keep looking. We'll keep looking. We'll keep looking. Oh, 75 and 12. 75 minus 12 is 63. We're getting closer. We're getting closer. I probably already went by it here. Hey, yep, I bet I did. I bet it was up there, and I completely missed it. 90 and 10. 90 times 10 is 900. And 90 minus 10 is 80. But I want a negative 80, so we would definitely use the negative 90 and positive 10. Oh, this takes forever here. This is half the video, just me scrolling through the mouse here. Let me see. I think I was yapping when I went past it, so I didn't even notice to point it out to you. Yeah, that's what happened. Yeah, 90, negative 90, and positive 10. Oh, better go back to notebook here. Going back to the notebook software, let's see. So negative 90, positive 10. And now we'll split it up. This time, we can help ourselves out. I'll put the minus 90m first, and then the plus 10m second. That way, we have plus minus, then plus minus. It's not a big deal if you don't do that. But just one less spot you can make a mistake. We got 9m as my GCF here on the left. And I don't have to, like I said, worry about my signs as much now because I already have plus and minus, so I can just divide them both by 10. So I pull that m minus 10 out, and then I'm left over with 9m plus 10. And that is how you do the AC factor. And yep, that's it. All right. So now, like I said, if you learn that possibly in algebra a different way, or if ever you've ever seen it a different way, the other way is basically guess and check, trial and error. So if you learned it that way and you need help on any of them with that, just ask and I'll help you with that. But overall, the class wanted to do it this way. Anyway, there you go. That's all the kinds of factoring we did this week.